Okay, good morning, afternoon, or evening, everybody. Welcome to the Lightning in a Flash using cloud and open source capabilities to improve data access and analysis Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. What I'll do is I'll begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat, and you should see that on the right. It's a panel on the right side of your screen. If you don't see it, there are three dots. There's a menu in the bottom right corner, and if you click on that, you should have an option to check, either the Q&A panel or the chat. Okay, today's webinar is being recorded. The recording will be posted both to the NASA Earth Data website as well as to our NASA Earth Data YouTube channel within a week of completion. And then once that is completed, what I will also do is I'll send an email to all registrants that will include the recording link and also a link to the presentation slide deck that's used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstration and an additional 15 minutes for the question and answer period. Okay, during today's webinar, we have only one speaker and we have two Q&A panelists. At this time, I'm going to actually pull up the agenda here. Okay, our speaker today is Dr. Jeffrey Stano. He is the GHRC DAAC scientist, and GHRC DAAC stands for the NASA Global Hydrometeorology Distributed Active Archive Center. He will begin today's webinar with an overview of the GHRC DAAC, and also the availability of lightning data at GHRC. While doing so, he will discuss the value of lightning data. And then from there, we will transition to an overview of the GHRC's transition to the cloud. And finally, we will spend the last part of this afternoon's webinar introducing and presenting a live demonstration of the GHRC DAAC's Lightning Dashboard. Once Jeffrey has finished with his presentation and demonstration, we will then transition to an optional set of final polls. I will generally leave these questions open for about 30 minutes or so that you have time to provide your responses as we go through the question and answer period. We are also pleased to have two Q&A panelists on the line during the Q&A period of this afternoon's event. Our first panelist is Will Ellett. He is the operations manager at the GHRC. And our second panelist is Navaneeth Rangaswamy, who is a developer at GHRC DAAC. Depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line, but we will have a hard cutoff of 3:15 p.m. Eastern Time. And I did want to say just one final note about the Q&A. We will try to address and answer all of the questions within the time allotted, but if we are not able to address your question during Q&A, our speaker will be able to follow up with you offline. With that, it is my pleasure to introduce today's speaker, Dr. Jeffrey Stano. And so, Jeffrey, at this point, I need to do two things. I'm going to stop sharing, and then I am going to close this first lobby poll, and then I will toss over the role to you.
Jennifer, thank you very much. I will start sharing my screen here. Oops, and we'll
Okay,
get
you
this
should
up.
you should have privileges at this point. Perfect.
There we go. I will
And there we
get
go.
things started over here. Swap the display. And we should be set to go.
All is
So,
looking good. Thank you.
thank you, Jennifer. And I'd like to thank everyone for attending here today. I've been watching everyone as they have been signing in. So I know we have people from all over. So I do appreciate the time at which you are signing in during the day. So thank you very much. Very excited to have everyone here and exciting to talk about our presentation, Lightning in a Flash, using cloud and open source capabilities to improve data access and analysis. Before I go into detail about that, I would particularly like to thank all of my colleagues who have been helping out with this project. As you've already heard, Will Ellett, he's our operations manager, Navneet Selvaraj, one of our developers, and Alan Sabetti, he is one of our student developers. They've been instrumental in helping assemble the Lightning dashboard that we will talk about today. And really, there'd be no presentation without all of their work. And so my thanks to everyone here for all your help to make this presentation happen. So thank you. As we heard Jennifer mention, the topical outline that I want to go with today is to really give a quick introduction about the GHRC DAAC. I'll talk shortly about myself and the program here at GHRC. I want to go into and discuss what is the importance of lightning data? Why do we care about it? Lightning is very transitory. It doesn't last very long. What makes it interesting to observe and to maintain an archive of lightning data? From there, I'll be sure to talk about the lightning data that we have available here at GHRC, and then start talking about our lightning dashboard tool, which has been developed. Now, you will notice I have thrown in a little bit about our cloud transition, and I think that transition is fairly important to how we've gotten to the lightning dashboard. And so I'll talk a little bit about that and why that's important for the lightning dashboard. And as you see through here, this is kind of a nice little image showing Hurricane Ian as it was approaching the U.S. state of Florida. And you're seeing right now the lightning through the inner core of the hurricane as it was approaching landfall. So we're going to be talking a little bit about how do these lightning data, how are they useful to end users? So let's start off with an overview of the DAAC. And as I mentioned, I'll briefly mention about myself. As Jennifer stated in the introduction, I am GHRC's DAAC scientist. So I have the opportunity to lead outreach and science integration for the program. It's really kind of a unique position to be in because I am a meteorologist by training, but I am working with the computer science department here at the University of Alabama in Huntsville. So it's a really exciting opportunity to be able to bring my meteorology background together with the computer science expertise of many of the people that work with GHRC. So it's a real fun opportunity through here. About myself a little bit more specifically, I've worked with the applications research focus for many years. I've done lightning safety, both for space launch and emergency management, focused on lightning applications in terms of severe weather decision support. Do we issue a warning or not issue a warning? And previously, prior to my joining GHRC, I was serving as a satellite liaison for the geostationary lightning mapper. And we'll talk a little bit about that instrument in the background to this presentation. So let's talk a little bit more about the Distributed Active Archive Centers, or DAACs, and specifically the Global Hydrometeorology Resource Center, or GHRC. The DAACs are part of NASA's Earth Observing System Data and Information System, or EOSDIS. There are 12 of us across the country, and overall, the role of the DAACs is to process, archive, document, and make sure that the data that we archive is freely available to the user community. And specifically, we're focusing on NASA's Earth science data. We want to make sure that the data that's collected from various satellite missions, airborne missions, field campaigns, ground instruments, we want to make sure that all of this Earth science data is available to researchers, available to end users. One of the major changes that's occurring with the DAACs as well is that we are evolving from being a curator of data. Just simply, data comes to us, we make sure it's made available for archival and then distributed out to users. We're moving from that curation only approach to making sure that we can start supporting end users with their research. And today's presentation is talking a little bit about what GHRC is doing to help enable that. Now, GHRC specifically, as I mentioned, we are the Global Hydrometeorology Resource Center. And we are a collaboration between NASA Marshall Space Flight Center and the University of Alabama in Huntsville. There's 12 DAACs, and each DAAC kind of has its own specialization in terms of the type of Earth science data that it supports. And specifically, GHRC is working to provide, and I'll read this directly here, to provide a comprehensive archive of data sets for the analysis of dynamical and physical processes of storm hazards, lightning, precipitation, tropical systems, and field campaigns. More recently, we have begun to start emphasizing cloud-based tools. GHRC is transitioning to become a cloud-only DAAC, and so we're working to kind of support those tools and capabilities and bringing in our own science expertise to help the end users with this. Currently, as of today, GHRC has about 84 terabytes of data in our holdings, and that actually makes us one of the smaller NASA DAACs. But we cover precipitation, hurricanes, lightning, storm hazards, any number of details along those lines. What's very exciting is that within the next year or so, we are anticipating that our holdings will more than triple as we go forward. So there's lots of data still coming into GHRC. So that's a little bit of a background about what GHRC is and about myself as the presenter. Let's start shifting into the value of lightning observations. What's the importance of lightning data? Why do we even care about something that's so transient as lightning? So we'll start off with a couple of fast facts with lightning. We know that globally, there's approximately 45 flashes around the world every second. So there's lots of lightning going on every single moment of every single day. We know also that about a third of those flashes strike the Earth. So when you get down to breaking things down where we have a little bit more information about cloud to ground data, we know that throughout the United States that approximately 25 million cloud to ground strikes hit the ground each year. So again, lightning is a pretty impressive phenomena when you look at these data over time. We also know that lightning is extremely hot, can reach up to 50,000 degrees Fahrenheit. So that makes it hotter than the surface of the sun. Now, one of the important things we have to look at when it comes to lightning is safety. And that is something that we've had a lot of progress within the United States, particularly over the past 20 to 30 years. That progress has been quite significant. At the turn of the last century, the US averaged about 400 individuals killed by lightning per year. In the past couple of years, that's now been brought down to less than 30 deaths per year. So we're making a lot of progress, but obviously still room to grow. This remains a major issue globally, though. Estimates are kind of difficult to come by. It's kind of a difficult number to track down, but it is understood that approximately 24,000 people globally are killed by lightning, with about 250,000 people injured each year. So the more that we can do to improve lightning awareness, improve understanding of where and when lightning will occur is going to greatly help these global safety issues. Lightning is also a damaging phenomena as well. However, it remains somewhat difficult to quantify. Lightning in particular is known for creating fires at structures and things like that, but sometimes that gets listed as simply a fire, not necessarily a lightning-started fire. But from the information that we do have, we understand that in the United States, about $451 million worth of damage is caused per year by lightning. Additionally, in the United States, there's been about 9,000 wildland fires from 2008 to 2012. In the image that you show on to the right here, this is coming from the geostationary lightning mapper. You can see on the right-hand side showing the goes east configuration, and on the left-hand side, the goes west configuration. So this is giving a nice space-based view of lightning, and you can see where lightning is occurring throughout a good chunk of the Western Hemisphere. And we'll kind of talk about that as we go forward here. So what can we do with these lightning data? Well, we do know that our observing capabilities have been improving. We have multiple ways to look at lightning data. First, we have ground-based instruments. These provide high resolution data, but generally a very small area to look at. There are global ground-based networks. Earth Networks, Vizsla are two of the most well-known, but those are privately owned networks, so you generally have to pay for those data to get access to them. We do have satellite-based observations, the aforementioned geostationary lightning mapper. They give you much wider coverage, but the downside is they have a lower resolution. Or in the case of the lightning imaging sensor, it is a low Earth orbiting instrument. So that means it's only giving you a snapshot over a particular part of the Earth before it moves overhead and then passes beyond you. But as we go forward, we're getting a better understanding of the intracloud component of lightning as well. And intracloud lightning flashes are very important, as they can make upwards of 90% of all of the lightning that's occurring within a thunderstorm. So this helps us with safety and decision support. Now we have the ability to start identifying what are called mega flashes, flashes that can extend for more than 100 kilometers in length. And I believe the record right now is now at 762 kilometers in length, which is pretty impressive. At the same time, too, we can look for lightning jumps. If you look at the upper left image, this regional image from a ground-based lightning mapping array, you see the red indicating the most concentrated lightning activity in a particular thunderstorm. So that gives you an idea of how intense is that thunderstorm. It gives you a proxy for what's going on inside that updraft. Additionally, going into that, talking about the lightning jumps, we can use lightning as a proxy for microphysics. And we can infer from the lightning activity we're seeing what is happening in convection, or in other words, the vertical motion within that thunderstorm. On a global scale, you can look at things at how it highlights regions of greater precipitation, particularly when radars may be unavailable. And also with the global scale, we can look to see where is lightning occurring, and we can look at this over time to see the evolution of lightning, see where lightning is changing its locations, and potentially see where precipitation patterns are changing. So let's talk a little bit about the lightning data that are available here at GHRC. We have a wide variety of data sets from space-based, airborne, and ground-based instruments. And from the metrics we've gathered every year, we have about 6 to 8 of our top 10 data sets come from our lightning data sets. And of those 6 to 10, the lightning imaging sensor is generally the most popular. And we can see through here, we have a wide range of space-based instruments going all the way back to the operational line scan system that covered the 1970s through 1990s, some data from the space shuttle, and then really we get into the main part of it starting in 1995 with the optical transient detector. And this really has served as the precursor to the lightning imaging sensor, as well as the now launched geostationary lightning mapper. I will mention for those who are interested with the geostationary lightning mapper, there is a kind of a sister instrument that EUMETSAT has produced called the Lightning Imager, and I believe that instrument has just launched. So again, that space-based component of lightning detection continues to grow. As for GHRC itself, we are anticipating continued growth in lightning data coming to our DAAC. We are anticipating a new global data set from the World Meteorological Organization. And this is an effort to try to bring together multiple data sets from both private and public vendors and to put them on a similar unified grid to kind of help with these data sets. At the same time, too, just last week, we started publishing our first gridded geostationary lightning mapper data here at the archive. So that is hot off the presses right now. If you're interested in the lightning data, I have the link through here, and I believe Jennifer's is putting it on the chat as well. You can go to the GHRC Earth Data Search portal, and you can look up for lightning. So for the past couple of minutes, we've talked a little bit about the GHRC DAAC. We've talked about lightning data, what makes it interesting, and also some of the lightning data that are available here at GHRC. So the last half here, last part of the presentation, I want to start talking about how are we using the data and get into the lightning dashboard. And that will set the stage for the live demonstration that I will do in a couple of minutes here. So really, before we can truly get into where are we going with the lightning data here at GHRC, I want to mention our efforts to transition to the cloud. So in other words, what do I mean by that? Our transition to the cloud means we're trying to move away from local on-premises hardware on computers to store data. So you come in, you log onto a local computer here to access data. We're working now to bring the data that we have at the DAAC and put it into a cloud-based server. And this really has some advantages. Now, the reason we're doing this is due to the rapid growth of Earth science data. If you look at the graph on the right, the most recent data is from 2022. We're showing that all of the data archived by the DAACs comes out to about 72 petabytes of data. That's a huge amount of data. But if you look towards the end of the decade with continuing missions that are ongoing and 12 new missions that are going to be launched, we're looking at having upwards of 600 petabytes of data by the end of the decade. This is an enormous amount of data that's coming in that has to be processed, archived, and made available to the user community. Even GHRC, as I've mentioned, we are increasing by at least 240 terabytes of data over the next year. So we anticipate to see even more than that as we go forward. Additionally, NASA has been working on this development of open science. And the effort here is to make data, capabilities, software more readily available to the user community. We want to make sure that all of this earth science data is being used by the community for your local research and for your various needs and efforts. So open science is also going to increase data as well, because we're trying to make these data more freely available. As I've mentioned as well, our efforts are shifting into these cloud services. So right now, NASA Earth data is using the Amazon Web Services. We're reducing our local computer storage capabilities. But by doing this, by putting data into the cloud, this gives us the opportunity to have potentially more cross-DAAC and even cross-agency data sharing. You as a user do not have to go to the GHRC DAAC or one of the other 12 DAACs to access data individually. You can do Earth data search, and the data are all combined up in the cloud. So you can do science in the cloud and access the data more easily that way. GHRC itself has been a cloud pathfinder for the DAACs. We started serving as the cloud pathfinder for Cloud Ops in 2019, and we were the first DAAC to have all of our data in the cloud by 2020. Also, we're anticipating that all of our operations will be cloud-based by 2024. So with that background, how does that start tying into our specific needs for Lightning? We know that working with Lightning data, these are complex files. You have two things that are kind of difficult to work with Lightning data. First, you just simply have a large volume of individual observations. You're trying to look at data in a very rapid temporal sense. So geostationary lightning mapper data, that's coming in every 20 seconds. Lightning mapping arrays, they're giving data every minute, but it gets broken down at the nanosecond scale. So these data sets are updating extremely rapidly. At the same time, too, there are multiple platforms for these data sets. So just because you have mastered one of these Lightning instruments does not mean you've been able to master the other one. So if you're trying to do derived products or intercompare observations from different platforms, it takes time to understand that, to create the processing. So what GHRC is trying to do, and all of the DAACs are trying to do, is start moving beyond that data curation where we simply make the data available and start trying to support our user community to work with these data. One of the earliest things we've done with this is a data recipe. And essentially, this is just simple code that we provide so that users can come in and do a basic manipulation, processing, and visualization of a data set. So that's a great way for showing from experienced people all the way down to students, how do you take a Lightning file from the various instruments, crack it open, and start doing something with the data. We also want to start trying to do some more complex things. So one of those is the Field Campaign Explorer. And what this does, this provides three-dimensional observations coincident with other field campaign data sets. And the image to the right shows the Field Campaign Explorer showing the Oklahoma lightning mapping array. And you can see one of the aircraft flying through, and you can see all of these little kind of tendrils. These are the individual lightning channels observed from the ground-based lightning mapping array. If you're interested in more information about FCX, you can look at our 2022 webinar through the link through here. But essentially what FCX does and what the Lightning dashboard is doing is trying to help us create basic analysis abilities for the user community. So the Lightning dashboard is something a little bit different from FCX. We want the Lightning dashboard to be something to quickly visualize multiple Lightning data sets, as well as being to offer some basic analyses. So what is the formation of the background? What was the reasoning that led to this? Well, the Lightning dashboard is coming out of our cloud experience and expertise and really wanting to focus on the open science capabilities. So FCX, or the Field Campaign Explorer, really gave GHRC a good background in how to start developing these cloud-based visualization tools and analyses. At the same time, too, the Lightning dashboard represents efforts with open science. And I say that because the NASA COVID-19 dashboard served as the foundation for the Lightning dashboard. So it highlights the abilities to take capabilities that are freely available throughout NASA and be able to transition them into new products and new abilities. Now, in terms of the development, we were provided funding for 1 year. And so the goal was to create a functional minimum viable product, or MVP, within that 1 year. And so what we are presenting today is the results of that 1 year effort. The goals for this, if we wanted to make sure that first, this was a cloud-based tool. So the advantage of a cloud-based visualization tool is that you do not have to download anything. You don't have to download the tool and you don't have to download the data. That's all being taken care of for you up in the cloud. We're also making sure that we focused on some of our most popular lightning data. In this particular case, the Tropical Rainfall Measuring Mission Lightning Imaging Sensor. And as you see through here on the left, we have a couple of basic visualizations. We're showing a flash rate density, as well as a couple of simple analyses. And the image on the left, we're showing a little slider tool. And we'll demonstrate that in the next couple of minutes. So let's talk about some of the technical details about this. First of all, the data that we work with are converted into cloud-optimized geotiffs. So the effort for this is we're moving into a data format that is designed to work and operate within the cloud. So it works faster, it's a little bit more easy to work with, you can manipulate it within the cloud and cloud-based tools. The cloud-optimized geotiffs are a nice data set to work with as well, as they give you good imagery, as well as the ability to make sure you have metadata embedded within those images, particularly geographical and spatial information. In terms of the software that we're using, there's a couple of different pieces of software that are being used to create the data. So we use React for the front-end interface. So everything that you'll see today in that kind of that display system is using React. We're also using the Amazon Web Services Lambda functions. And so essentially, those are little bits of code that we use to create the individual tools and capabilities. And we'll show some of that with the metadata filter during the demo. From there, a lot of the heavy lifting is being done by Terracotta Python. This works as our tiling server. And this is really what helps us start kind of bringing in all the data, and it's part of that dynamic visualization that we're working with. Lastly, in terms of what are the maps that we're using a system called Mapbox. This is similar to, for those who are familiar with Cesium.js, we use this for the Field Campaign Explorer and for using three-dimensional displays. For the Lightning dashboard, we're primarily focused on a two-dimensional display, and the Mapbox is best known for those displays. So what does this do for our capabilities? We can do some basic flash rate densities. We have the slider comparison tool. We have a histogram tool as well. And we can do some basic data analysis. At the same time, too, if you look on the upper right, I'll kind of point through here. We have a dynamic zoom capability, and I'm focusing on Australia right now. If you look at this, you're pretty zoomed out. We're looking at the entire continent of Australia. And so you can see a general smoothing of where the lightning data is located and observed. If you kind of look a little bit to the this bottom central part of the image, we are more zoomed in on the continent of Australia. And you can see how the resolution of the data has improved. As you zoom in, you get more of the higher resolution data. And this dynamic tiling is designed to make it faster and more reactive to visualizing the data. So you can pan and zoom and work with the data. And so I will wrap up with this slide here and then drop directly into the live demonstration of the Lightning dashboard. But where are we going with this? As I mentioned, this is just the MVP product, or the minimum viable product. We've had 1 year to develop this and work with a couple of our data sets. We really want to start incorporating additional visualizations within the Lightning dashboard as we go forward. There's more density products that we can work with. Also, we can update our color curves. So essentially, we pretty much have some very basic color curves through here. We'd like to get more detail in those color curves so that users can extract more information just by visually inspecting the data. There's a number of analysis options we would like to look at, in particular looking at intercomparison data sets. That's going to be useful. And lastly, we want to incorporate additional Lightning data sets. So we want to bring in more of the International Space Station Lightning Imaging Sensor, and the ground-based lightning mapping array data that we have archived as well. Additionally, as we go forward, we want to make sure that as an MVP, this was deployed in a local cloud instance. But we really want to start eventually moving this to an open source software. So it's open source release so that users can come in and access the code themselves and either kind of develop it on their own, or they can come in and offer their own capabilities to the Lightning dashboard as well. And so with that, first of all, thank you again for everyone's attendance here so far. I will ask if we can just hold questions to the end of the live demonstration, and we'll go forward from there. And if you give me one moment, I will pull up the demonstration and go forward from there. And Jennifer, just to make sure I am doing everything correctly, are you able to see a map of the world from the dashboard?
Yes, I am.
Excellent. Thank you, Jennifer. Okay, so for the next couple of minutes here, I'd like to kind of walk through the Lightning Dashboard tool and what it can do so far and where we're trying to go with this. And also, this might help answer some questions that you may have based on the presentation. So a couple of things I want to work with. If you go to the right-hand side, there's a nice little information button you can click on. Gives you a nice little welcome. It talks about the navigation bar on the left. We can toggle different layers, and then a timeline tool as well. I can click on that once again for you. As time goes on, as we continue to expand this, that information button will provide more information as we go forward. Now, if I can direct your attention to the upper left, there are two items I want to draw your attention to. There's layers and also links. Let's start with the links. What we're doing here, and with everything that GHRC is doing, and honestly all of the DAACs are doing, is we want to make sure that the capabilities that are developed provide not just not just a visualization capability, but a data exploration capability. So what do I mean by that? We want to make sure that if you are interested in more information about the data you are looking at, you can quickly get access to that information without having to necessarily go to a Google search or something like that. So one of the data sets that we have is the Tropical Rainfall Measuring Mission Lightning Imaging Sensor, or the TRIM-LIS. I can click on that, and that quickly takes you out to the Earth data, NASA's Earth data page, where we can get information about the LIS, or the Lightning Imaging Sensor data that we have available. So here's a nice quick little blurb about it. We can come through, go to the documentation tab, and then go to the user guide that provides information about this data set. So you can scroll through, there's an introduction, how do you cite the data, making sure that, again, credit is given where it's due, and go through and get all kinds of information about this particular data set. At the same time, too, this can also take you to where you can download the data as well. And you can show with Earth Data Search, and that takes you to the download links we can work with these data. So that's something that's very important to us to make sure you can follow where these data are available, get more information if you're interested in the data set. Now, let's look at the layers. Let's actually start getting into this. We've talked about it in the presentation. I've shown some nice little background information. But let's dig into it. Let's really look at some data now. So the first one I will work with is the Tropical Rainfall Measuring Mission Lightning Imaging Sensor data, and I'll look at the full data set. And again, we can toggle this open and close. So there's TRIM-LIS, we can open that up. And you'll see a couple of different displays. I'll look at the full data, and you might say, well, what does that mean? Well, here's a nice little information button I can click on. I can click on that, and it says, this shows the entire mean flash rate density from 1998 through 2013. Okay, that's very useful. So that lets me know what I am looking at. So let's turn that on. Let's toggle that and see what we're working with right now. So as you see, this is showing the TRIM-LIS full data set of lightning observations. And you'll notice a couple of features through here. And first of all, I can show how we can pan around the map. I can zoom out. I can zoom into India. We can see a very interesting display of lightning, particularly along the Himalayas. We have a lot of convergence during the monsoon season into the Himalayas, creating a lot of convection and lightning activity. It's also showing that dynamic display. As we zoom out, it smooths. As we start zooming in, you can start seeing the higher resolution data. Another feature you might notice is this interesting cutoff right around 33 degrees north and south. This is due to the orbital characteristics of the trimless data. It didn't go any higher than 33 degrees north and south. At the same time, too, I can zoom out through here. We can also turn this data set off, turn off the information as well. And again, I can start showing seasonal data. And now we're looking at the springtime northern hemisphere. And this is kind of going to the fall of the southern hemisphere through here. What's interesting at this, we can also turn on an animation. And we have a little 5-second delay, and then it will jump to the summer season. And again, when I say summer, I'm referring to the northern hemisphere summer right now. And now we're moving into the northern hemisphere autumn, and you can see how the lightning is shifting from being in the northern hemisphere, from the southern hemisphere to the northern hemisphere, and then it goes back to the southern hemisphere as we get into the northern hemisphere winter. And again, obviously, we can look at a couple of things. We can look at monthly data, and I can manually click through that as well. Here's March, June, once again showing the evolution of lightning, the seasonal transition of lightning as well. So let's go back to the full display as well. And you'll see something that's been kind of blank on the right-hand side, which is a render chart capability. And I will click on that. And this is a ability that we've been working on through here. We wanted to bring this in for the presentation. And what it does, it is showing the flash rate density for the full trim-liz data set. And we're looking at this as kind of a histogram where we show flash rate density in the z-axis. We are looking at the latitude in the x-axis, longitude by the y-axis. And you can see through here, where are we expecting to see the most lightning from these observations? And that is kind of corresponding to roughly this region right over Central Africa, a very highly active area, a large region of lightning activity. So another one of these kind of examples of some of the tools that we're trying to develop to help analyze these data as we go forward. At the same time, too, let's kind of look at some of the other capabilities that we can do. When we're done with the chart, we can just remove that. And if you don't like that space there anymore, there's a little button in the upper right. I can click on that, and now we can see pretty much the whole globe worth of data at this stage. Now, at this next step, what I'm going to do, I'm going to turn off the trim Liz data, and I'm going to go to the monthly Liz data. And there's a particular reason for this through here. Once again, it's going to pop up the render chart if we wanted to look at that. I don't want to look at that right now, so once again, I'll close it. And we have a capability to scroll down on the left-hand side, and there's a little thing called baseline image. I'll click on that. I can click on datasets. And I'm going to do OTD monthly, or the optical transient detector monthly. And then there's a little calendar feature that I need to click on to choose the proper time frame. And on the right, I used January for trim, and I'm going to use June for the OTD. So when I do that, and if I click on the calendar a second time, that little calendar pop-up goes away. What's interesting here is you can see the difference between the two instruments. The optical transient detector had a much larger orbital dynamic. So it went up to about 60 degrees north and south, as we're seeing through here. And you can see, if I move that slider back and forth, I can kind of show you where the lightning is versus the trim versus the optical transient detector. At the same time, too, if we kind of zoom in on, let's go to South America through here. I'm trying to get multiple points across the Earth here. On the right-hand side of the slider is January data. And so that's going to be the summertime for the Southern Hemisphere. So a lot of lightning through there. And as I move the slider over South America, we're moving into June. So the Northern Hemisphere summer, but the Southern Hemisphere winter. And we see that the lightning activity drops off fairly significantly. Now, there is going to be a little bit of difference in magnitude due to the optical transient detector being a little bit of an older instrument. But again, this slider tool gives you that nice little capability to compare and contrast the two data sets. And as I start kind of wrapping things up, once again, I'm going to kind of clear things out. I'm going to go back to the trim Liz full. I'm going to refresh the page first. We'll go back to the trim list full from the layers tab on the left-hand side. And once again, I'm going to close the render chart through here. And what I would like to show at the next point is the metadata filter. So I mentioned this during the presentation. We can use these Amazon Web Service Lambda functions to kind of pull information out, to do some processing on the data. So one of the things we're going to do, we're going to do this metadata filter. And what that's going to do for us, we can actually pull out the individual point data that was observed throughout these data sets. So I'm going to narrow this down. Let's kind of focus a little bit more on North America. I'll put this about, well, okay, kind of Eastern North America. We'll go from roughly the Eastern Atlantic all the way over to North America. Longitude, we'll bring that up to about the equator, up to about 40 degrees north. And we're going to keep the flash rate density from 0 to 100. So we're going to look at everything. I'm going to click on render. Now, you quickly get a pop-up to acknowledge your request. We're going to hit OK there. And then we'll get a second pop-up indicating that the request is being processed. Right on time. Data received, points will soon begin rendering onto the map. And already we have a couple of these through here. And for time, I won't wait for everything to come in. So I'll just kind of zoom in over Central Africa through here as things are being processed. And I just realized instead of doing, I did my longitude and latitude backwards. So I apologize for that. So we're going to be the Southern Hemisphere. But what we can do, we can zoom in and we can see where the individual point observations are occurring. And these dots indicate each little kind of point of data, and they're scaled by how much lightning is being observed. So smaller points, smaller data. And this particular one has a latitude of nearly -4, latitude and almost 20 degrees longitude, and has a flash rate density of about 47 flashes per square kilometer per year. And what this is, we wanted to do this particular tool so you can dive into the data a little bit more. So you don't just have this blank image showing a density. You can actually look at that distribution more clearly with this individual component through here. And so finally, once again, I'm going to clear the web page here. And I will go down to one last display. Excuse me. And the last one is a hotspot data set. And I'm going to click on this real quick. This is kind of showing the capabilities of what we can do with the tools and resources within the Lightning dashboard. What's interesting is there was a paper done by Rachel Albrecht from 2016, which took the trim list data and identified the top 50 most lightning active spots on the Earth. And so we can take that information from that paper and put it into the Lightning dashboard. So we can now look at, once again, that trim list full display, complete with those 50 hotspots. And in particular, I'm going to zoom in into Venezuela through here, and I'm going to go towards Lake Maracaibo. And it's a little bit difficult to see right now, the map beneath it. So what I will do, I'll go to the opacity on the left-hand side. I'll drop that down to about 60% here. And you can then see, here's Lake Maracaibo, and there's a hotspot right over it. So I will click on the hotspot, and this is the global rank of number 1, the most lightning-prone area on Earth. From Dr. Albrecht's paper, there is 232 flashes per square kilometer per year at this particular point from the data set. And if you're interested, you can always follow that to start downloading the data. So with that, we're coming up right at the end of the 45 minutes of the presentation, and I believe I will end it here. And once again, thank everyone for your attendance. It's always fun to give these presentations, and I will look forward to the questions.
Okay, thank you, Jeffrey. At this point, what we are going to do is I am going to take the presenter role back from you, and then I'm going to open the final polls, and then we'll jump straight in to the Q&A period. So if you could give me just one moment here. How do we acquire real-time lightning density, or is that a possibility? Lightning density data.
That is a great question. There are currently two near real-time data sets that are available at GHRC. You can follow the search.earthdata.nasa.gov and go to the GHRC portal. And I believe Jennifer put that in the chat at one point here. And I also have that link included in the presentation slides. And then you can type in lightning. In particular, you are looking for the North Alabama Lightning Map Array. That is in near real time. But really, that's only going to help you if you are living over under the Lightning Map Array here in northern Alabama. The other instrument you can look at is the International Space Station Lightning Imaging Sensor near real-time data. That's updating approximately every 2 minutes. That has a global reach, but the main drawback to that is the orbit of the International Space Station means it's not in a geostationary position. So you're not staring at the Earth 24/7. You're just getting a snapshot of where the lightning is occurring wherever the International Space Station goes over. So that dwell rate is about 90 to 120 seconds. So those are the best options for near real-time data at GHRC. We do have the geostationary lightning mapper level 3 data that are coming. I believe that is not going to be a real-time data set. I believe that's going to be updated every evening US time. Anything else that you're looking for in terms of real-time data, you can look at potentially NOAA for the geostationary lightning mapper, and also the private vendors provide information, do provide data in near real time. Unfortunately, those you have to pay for.
Okay, thank you so much, Jeffrey. All right, and I'm just scanning. I've opened the polling questions. Sorry for the delay on that. And moving down to the next question in the chat. Maybe the question I was thinking of was asked a little bit later. Can we download gridded level 3 data of a lightning event up to the current date over the Indian subcontinent?
Up to the current date. Yes, that is going to be the International Space Station Lightning Imaging Sensor data. So that will cover the entire Indian subcontinent. Unfortunately, that will have the caveat of being a low Earth orbiting instrument, so you're not going to be able to see that continuously over your location. We can also go to the TRIM lightning imaging sensor climatology, so that aggregates the 16 years worth of data from that instrument over the Indian subcontinent or anywhere where you have TRIMLIS data to give you some information. But unfortunately, in terms of finding complete coverage over the Indian subcontinent, no. The best is going to be the ISS lightning imaging sensor.
Okay, thank you very much, Jeffrey. And let me get to the next question. And then again, after that, we'll jump into the Q&A panel to grab our questions, but there are quite a few. So one of the questions was whether or not we will provide the video recording. And the answer is yes. There's a little bit of post-processing that is involved. And so it should take a couple of days for me to get the link to the recording as well as the link to the presentation slide deck out to all registrants and participants. So be expecting that in the next couple of days. It will not be available immediately, okay? But I most certainly will follow up with everybody. Okay, so the next question is, are the data from LIS on TRIM and ISS the same or different? Is there discontinuity in lightning data?
That's a great question. They are actually the same instrument. The International Space Station Lightning Imaging Sensor was actually the flight spare for the Tropical Rainfall Measuring Mission Lightning Imaging Sensor. Say that 5 times fast. And so TRIM-LIS provides observations from about 1998 through 2013. I think there's a little bit more data beyond that. But it's going to be in that 33 degrees south to 33 degrees north. Afterwards, there's going to be a several-year gap. And then the International Space Station Lightning Imaging Sensor, it begins in around March 2017 and is ongoing today. That mission hopefully is going to continue through at least this year, and if we're lucky, maybe for another year or two beyond this. Overall, they should provide generally the same information. The TRIM-LIS data has a couple more added data sets. There's a very high resolution climatology that's been produced. some additional add-ons that the International Space Station version has not had produced just yet. I think that's going to be coming in the coming years here.
Okay, well, thank you very much, Jeffrey. The next question is, can you say a few words about the advantage of using trim data over GLM data?
Oh, that's that again, another great question through there. The geostationary lightning mapper data, the advantage for that is that its position in orbit. It is fixed over a single point on the Earth, and so it's giving you continuous observations over its field of view, so you can watch a storm from start to finish and see the entire life cycle of the storm. Uh, you can, but the disadvantage to GLM, if we go back to that early map that I showed, is that it's generally only showing the Western Hemisphere. Now there is the sister instrument, the Lightning Imager that EUMETSAT is launching. That's going to cover Europe, Africa, and out into the Indian Ocean. So their advantages are continuous observations. The TrimLIS data, its primary advantage is that it gives you space-based observations dating all the way back to 1998. The earliest GLM data is 2016. So you have a much longer period of record from the TrimLIS data, as well as being able to see parts of the Earth that are not covered by the GLM. Now, the advantage, so that is a nice advantage. You can also look at it for long-term trends, the evolution of where lightning might be happening on an annual basis. But unfortunately, as we had with the previous question talking about the Indian subcontinent, the TrimLIS does not provide continuous observation over a given point. So that's going to be the main drawback from TrimLIS.
Okay, perfect. Thank you. And I am seeing the question I had thought was in the chat, but was actually the first question asked in the Q&A. So we're going to jump down to the Q&A panel, and then I will jump back up during extended Q&A for those additional questions that have been asked in the chat. So the question is, are the block diagrams and inside details of these imaging systems available? And that was in reference to one of your earlier slides as we started off.
Oh, yes. The all of the data. Let me try that again. I apologize. All of the data sets that we have archived, we will generally have some simple little block diagrams. We can. I think we have references to the actual block diagram. So we're using just kind of a lower resolution version of that. But for everything that we do have archived, excuse me, from optical transient detector, geostationary lightning mapper, the lightning mapping array, all of those will have user guides which will explain the data that are available. So you can go in, see all the variables, all the details about those particular data sets. So yes, there is documentation and there is information about those. If there's anything that you need that you're not seeing, please reach out to us and we'll be happy to help identify where we can find that information for you.
Okay, thank you very much. The next question is, how can I have access to TrimLIS monthly and daily data for each year from 1998 to 2013 instead of the mean?
Oh, okay. What you can do is again follow the search at earthdata.nasa.gov. Go to the GHRC portal. Again, that's the link that was provided. Jennifer, will I break the polling if I share my screen at the moment?
Yes, you will.
Okay. All right. So I won't do that right now. But what you can do, go there, select Lightning, and what you're going to be looking for is the TrimLIS Very High Resolution Lightning Climatology, VHRC, Very High Resolution Climatology. And that one of the subsets from that climatology is going to be the monthly data. And again, at the end of the presentation, I had my email address on there. So please feel free to reach out to me if you have any questions about getting access to these data.
Yes, perfect. Thank you so much, Jeffrey. And so the next question is, what numerical scale corresponds to the Lightning dashboard's poor through exceptional color scale? FRD 0 flashes per square kilometer per year to what maximum value?
Okay. That is definitely a realm that requires more work. As we were developing this as kind of a minimum viable product, we did not spend a lot of time and effort on refining the color curve. So what you're seeing through here is we're going up to about 100 flashes per square kilometer per year as the highest flash rate density. And so that poor to high, we're literally using a default tool within the display system. What we are doing next is we need to go in and start implementing some of the color curves that are used either operationally or from some of the other research efforts that have gone on so that the displays match better with what's out there right now. So this is basically what you're seeing is just kind of our initial demonstration, and we will be enhancing that as we go forward.
Okay, wonderful. Thank you. So you may have answered this to a degree. Is it possible to have access to the data, for instance, trim lists itself from the Lightning dashboard and to download the data and the image or analysis?
Oh, that's interesting. That's a very good question. I can hand it off to my colleagues Will and Navaneeth. I know there's some capabilities that we have been wanting to do with the Field Campaign Explorer. Uh, Navaneeth, I'll hand it to you. Is that something that can be done, or is that something that's in the works already?
Right now, it is in the works, Jeffrey. So we are working on the subsetting tool where you look at the data and you select the coordinates and you get the exact data downloaded. Right now, it would just point you to the repository where all the files are available.
Well, thank
Okay,
you.
great. Navaneeth, thank you.
Thank you so much. Okay, so the next question is there any access to GLM data at the individual flash level, time, location, morphology, etc.?
There's two options for geostationary lightning mapper data. The first one is as of I think last week, we will have what's called the level 3 gridded data. That's going to be available at GHRC. Probably by next week, we should have a lot of that cleaned up and ready to go. That is a derived product, so you will be unlikely to get individual flashes from that particular data set. If you want to get down to the individual lightning flashes, you can go to the NOAA class system, CLASS. And I forget what the acronym stands for, but that will let you access the level 2 data, which will allow you to go down to the individual events, groups, and flashes of GLM and to work with those.
Okay, perfect. Thank you so much. So the next question is, let's see, when will the ISS list data be available?
On the Lightning dashboard, that is one of the next data sets that we want to bring in to the Lightning dashboard. We have a very basic version of it in here so far. The main difference is that for the trim data that you see, we were using that very high resolution climatology as the data set. And the ISS LIS data does not have a very high resolution climatology to work with just yet. So it's going to be a little bit of an apples to oranges comparison right now, but we are working on that. We're working with the NASA Marshall Lightning Science Team, which manages the ISS LIS instrument, and we will be working to update that going forward. Unless Navaneeth, you have anything additional to that, I don't think we have an exact time frame for that just yet. Okay, yeah. I'll get a thumbs up for Navaneeth. So yes, we don't have an exact time, but we will be working on that.
Okay, perfect. Thank you so much. Another question I see popping up in the chat. Yes, the recorded video will be made available within a couple of days. If not the latest, early next week. There is some post-processing that is involved, but certainly I will follow up with an email for all registrants and participants. And again, as a reminder, we're in the extended Q&A. I will cycle through the remainder of the questions that are in the Q&A panel and then hop back up to the chat so we can address those as well. The next question is, are the data processable using traditional tools like ArcGIS?
Yes. If you go to the GHRC webpage, and I believe I provided a link to the main GHRC page, you can search for our data recipes. And we have a couple of data recipes which will allow you to take in optical transient detector data or the trim LIS data, convert it into CSV files, which can then be worked on in ArcGIS. Longer term, GHRC is beginning to participate in what's called the ArcGIS DAAC collaboration, or ADC. And the effort here is to try to bring together all of the DAACs working with GIS data and to kind of create some tools and capabilities to better use those data sets. So stay tuned. We are looking at that, and we've gotten a couple of requests along those lines in terms of GIS data. There's a lot of interest to go from there.
Okay, perfect. Thank you, Jeffrey. The next question is there a schedule for when the Lightning dashboard will be available as open source? I see what is maybe the beginning of that effort here. And then there is a GitHub link, GHRC DAAC / lightning-dashboard that the user has provided.
Do you want
And
me to take
yes,
that
I do see that. Yes, please, that'd be great. I do see an initial response from Navaneeth in the Q&A, but please do elaborate. Thank you.
So actually, and it's open. You know, it's based on an open source project. It's based on the COVID dashboard, and so you know, it's freely available. I don't know that we're, you know, we did look at open sourcing it individually, but I don't think there's, you know, it's already based on an open source project, and so it is freely available.
Okay, thank you, Will. The next question is trim list data available up to 2022? I am only getting up to 2014.
It is only available up to 2014, as that was the end of the mission. By that point, the satellite had finally run out of fuel and was deorbited by that point. So it goes to 2014. If you want to work with LIS data beyond that, you'll have to work with the International Space Station LIS, which starts in March 2017 through today.
Yes, thank you. All right, so the next question is, will any of the anticipated data sets be able to distinguish between cloud to cloud and cloud to ground? And will any data, indicate plus or minus polarity?
For the most part, particularly with the satellite-based data, there will not be any real capability to identify cloud to cloud versus cloud to ground lightning data. The reasoning for that is the space-based instruments are operating in the near visible spectrum. So you're literally detecting light being emitted through the cloud top and then being observed by the satellite. So there's really no easy way to identify whether or not that came from an intracloud flash or a cloud to ground flash. So the main data set that we have that could actually do some of that for you are the lightning mapping array data sets that we have. Those can map the individual lightning channels. You can see it as it comes to the ground. But the problem is those have an extremely small domain of operation. We're talking about a radius of maybe 150 to 200 kilometers at most. So you won't be able to do much with that. There is some processing that can be done with the LMAs to be able to look at polarity of the data. And we're working right now to potentially use some community code that's already been developed to potentially bring that in to help with the processing to create that style of data. So unfortunately, if you're looking for something wider than the lightning mapping arrays, that's going to be something that will fall under the purview of the privately owned networks such as Vistla and Earth Networks.
Okay, thank you, Jeffrey. Let's see here. Okay, so the next is kind of a combination comment and question. A hotspot is not necessarily related to a high number of deaths. What do you think about people's I guess this means about the people's exposure to hazardous lightning. Do you have any tips to mitigate the risk of death?
That is a very insightful question through there. Absolutely correct. Just because you're in a hotspot or an active lightning area does not necessarily mean that's where you're seeing the most fatalities or injuries from lightning. A good case in point is take Central Florida. You have the city of Orlando, the big theme park of Walt Disney World. These are very high density population areas that are also located in the most lightning prone location in the United States. But we don't see a lot of, thankfully, we don't see a lot of lightning fatalities or injuries in this region. That is really starts going into socioeconomic discussions. The United States over the past 100 years has become more urban versus rural. More of the jobs are indoors versus outdoors. At the same time, too, the means of transportation is generally people are in a car versus walking. So again, looking at those types of features, you shift over to other parts of the world where structure, there may still be structures, but they're not grounded. You look at, I mean, like the building I'm in right now, that we have wiring, we have lightning rods that bring cables down to the ground to protect the building. You go to other parts of the world, you don't have that. And so you may have a building, but it's not necessarily any safer than whether or not you were standing outside. So this is a really big issue in terms of lightning safety. And I think to get into your question, how do we work with this? That kind of comes down to it's a multi-pronged approach. There is education, teaching individuals where are safe places to go. Don't stand under a tree. Go to a building. Whether or not it's a reinforced building like I'm in right now or other buildings, generally the building is going to be better than being under a tree. That goes into public outreach. In particular parts of the world, we're looking around Lake Victoria in Africa. There has been outreach efforts to help reinforce school buildings. The school buildings are often a central part of the community. And so if those buildings have lightning rods and lightning mitigation systems, those buildings become a safe location. They're also looking at doing various things of creating small lightning shelters for individuals who are working out in the fields. Other things you can do is look at the lightning data and look at it in terms of diurnal observations, seasonal observations, and understand when is the most lightning prone times of day. And if you can do that, you can at least look at things in terms of seasonality and time of day and potentially help educate people as to what are the best times to be working outdoors. Because again, if you're farming, things like that, you can't sit in your office and farm. You have to be outside. And so if we can educate and provide information about that, that will help improve the safety component. And there's a number of individuals who are trying to work on this issue. So if you have more questions, please feel free to reach out to me on that.
Okay, thank you very much. The next question is, it's actually two parts. Is Amazon the only cloud server right now? And are there any plans in the future to use any other cloud server? And then the second piece is, and the other question is, can we do data processing in the cloud server, or do we need to download for processing? Because in the last slide of the presentation, there was a download tab in the menu of the location details.
Good
I'll take this
questions.
one, Jeffrey.
Oh,
I'll take this one.
thank you, Will.
Yeah, so it is an Amazon AWS, and there aren't currently plans to move to another server or another web cloud technology. I think there has been some DAAC, looking for down the road at the future of where that might be. But as it stands right now, AWS or Amazon is where we are doing our cloud work. And as far as can you use clouds? The data is available in the cloud, right, in AWS. And so if you do have some AWS resources, you could process this in the cloud. Yes, you do not have to download it. That option is there, for if you don't have any cloud resources, then yeah, you can also download it. And that's why you have that link so that you can download it.
Okay, thank you, Will. And now I'm jumping back up to the chat. So one of the questions that was asked is, can you please discuss, I'm interpreting here, okay, based on my understanding of how this question is worded, between the difference between science data and non-science data, or science data and background data. So I hope I have captured this properly. And if not, please feel free to provide additional information in the Q&A.
I need to unmute myself. Jennifer, that was a good interpretation of it. The background data versus the science data. Essentially what that is, the background data means there is a camera, or essentially a camera on lightning imaging sensor, geostationary lightning mapper, those instruments that's looking down and looking at the cloud field beneath it, or looking at the Earth beneath it. That camera is creating a background image of what's happening beneath the instrument. Then you have, say lightning occurs, a flash of light happens, and the instrument and the processing then has to compare the light from that flash to the background. And when you exceed a certain threshold, the processing algorithm says, that's a lightning flash, flag it as lightning, and move forward. So what you have then is the two data sets are the science data, that is all of the data that the algorithm has flagged as a lightning flash. In other words, light that has exceeded a threshold of the background. And the background data essentially gives you a low resolution image of the Earth from which it's observing lightning flashes. So you can almost think of it kind of like a weak visible band imager.
Okay, perfect. Okay, so the next question is, does GLM cover Sri Lanka?
Unfortunately, no. The GLM does not cover Sri Lanka. There is, and the lightning imager from EUMETSAT, that will not cover it as well. I do know there's efforts that there likely may be from Korea to potentially launch their own version of the instrument in the future. And also, I know that EUMETSAT over time, as they launch new satellites, they shift the existing satellite further east, and which then covers more of central Indian Ocean. So while it's not available now, potentially by the end of the decade, we could potentially see something that would cover that region.
Okay, thank you, Jeffrey. I think we're going to have time for one, possibly two questions. We'll see because we're almost at our endpoint. Do you have a timeline for when the TMMR data will be open source?
The trim data will be the trim data are freely available right now. The open source is referring more to code being available to manipulate code and things like that. But if you go to Earth Search, you're freely able to get the trim LIS data now.
Okay. Hopefully that's what they're referring to. It's actually worded TMMR, and I was thinking, I'm not familiar with that. So the trim data, okay. Let's do one more question, and then we will leave the virtual meeting space open. If you think of anything, even if we didn't have time to address the question during the webinar itself, our speaker will be able to follow up with you offline. Final question, what are the challenges to change lightning data to other variables, say precipitation, clouds, or winds?
Ooh, that's got the hard one here at the last moment. Oh, we're out of time. The main issue with that, probably the closest one you can work with is precipitation. The reason for that is that we can understand that lightning is associated with convection, so vertical updrafts. And we know that the relationship of lightning to the vertical updrafts is a nonlinear relationship. So the more lightning you have, much stronger updrafts are occurring. And so you can use that to potentially create a proxy for precipitation, or maybe not directly create precipitation, but to enhance precipitation algorithms that you may have, particularly since convective resolving models are still not necessarily widespread use, but they are definitely becoming more and more popular. In terms of wind and other features, again, I think that's going to be a situation where lightning is not going to directly tell you what those variables are, but will serve as a proxy for what is happening within that convective system to then modify and enhance any sort of forecasts or predictive capabilities for those other variables.
Okay, well, thank you very much, Jeffrey. And at this point, what I'd like to do is thank our two Q&A panelists, Navaneeth Selvaraj and also Will Ellett. And thanks to my backup hosts for their participation today. And thank you to our speaker, Dr. Jeffrey Stano, and also to all of you for joining us this afternoon. We will log off from the audio component, and I will leave the Q&A open, and the polls, I think they have a few more minutes as well. So certainly if you think of something, please feel free to enter that information. And with that, we will log off from the audio, and thank you very much for joining us.
Yes, thank you, everyone. And Jennifer, thank you as well.
All right. All right. Goodbye now. Thanks, everybody.